Okay. ओके, सो अभी हम लोग ये पेपर डिस्कस कर रहे हैं मिड टर्म का। मिड टर्म 2024 पेपर 2 है, ठीक है। इस पेपर में सबसे पहले हमसे ये पूछा जा रहा है, क्वेश्चन नंबर 1, कि अ जेट ऑफ वाटर हिट्स वर्टिकली एट राइट एंगल ऑन द वॉल, और आपके पास गिवन क्या क्या है, आपके पास डेंसिटी ऑफ द वाटर गिवन है, आपके पास वेलोसिटी ऑफ द वाटर गिवन है, और एरिया ऑफ द क्रॉस सेक्शन ऑफ द पाइप गिवन है। और ये जब जहाँ पे जाके हिट कर रहा है तो कह रहा है कि वाटर रिबाउंड नहीं होता, सारा वाटर आपका क्या है, वर्टिकली फॉल डाउन करता है। तो शो दैट द ओवर 1.6 seconds the mass of the water hitting the wall is 1.2 kg। तो आपको मैस बताना है। मैस के लिए आपको ये पता है कि हमारे पास वॉल्यूम, डेंसिटी, ये सारी चीजें यूज हो सकती हैं। तो सिंपली मैस इज टू वॉल्यूम इनटू डेंसिटी, ऐसे ही है। क्योंकि डेंसिटी आपके पास क्या होता है, बिकॉज डेंसिटी इज इक्वल टू मैस डिवाइडेड बाय वॉल्यूम होता है। तो मैंने इस फॉर्मूले से ये एक्सट्रैक्ट किया। अब आपके पास डेंसिटी गिवन है, ठीक है, मैस इज इक्वल टू डेंसिटी इनटू वॉल्यूम कर लेते हैं, चलो ऐसे। अब आपको वॉल्यूम को एक्सटेंड करना है। बात समझ आ रही है बच्चे?
जी
वॉल्यूम
सर।
आपके पास होता है बेस एरिया टू लेंथ। अब आप थोड़ा सा और एक्सटेंशन करोगे। अगर डेंसिटी गिवन है, एरिया भी गिवन है, क्रॉस सेक्शन, लेंथ क्योंकि कांस्टेंट स्पीड से वाटर मूव कर रहा है, तो आपको पता है कि आपका जो एस है वो किसके बराबर होता है, वीटी के बराबर होता है। यानी लेंथ आपकी किसके बराबर हो जाएगी, वेलोसिटी इनटू टाइम के बराबर हो जाएगी। तो ये बेसिकली एक फॉर्मूला है जो आप याद भी कर सकते हो, और सिंपली आप इसको यूटिलाइज कर लें, क्योंकि ये फॉर्मूला मोस्टली हमें कैलकुलेशंस में काम आता है कि मैस इज इक्वल्स टू ए वी टी, एरिया इंटू वेलोसिटी इंटू टाइम। एरिया ऑफ क्रॉस सेक्शन आपके पास कितना है, 1.5। कैलकुलेटर रेडी रखना है ताकि हम कैलकुलेशंस अपनी सारी कर सकें। वेलोसिटी 5.0 है, और टाइम इसका कितना है, 1.6। तो करिए जरा, क्या आंसर आएगा।
ओके।
अब बस यही 1.5 ही आना चाहिए, 1.2 kg आना चाहिए ऑलमोस्ट। कैलकुलेटर है ना?
1.2 टाइम्स 10 पावर ऑफ -3।
है
1.2 टाइम्स 10 पावर ऑफ -3।
हम्म। ओ सॉरी सॉरी सॉरी, मैंने डेंसिटी को यहाँ मल्टीप्लाई नहीं किया, ये भी थी, डेंसिटी भी थी। डेंसिटी आओगे 1000। अब करिए, तो योर आंसर विल बी 1.2। ठीक है, बात समझ आई?
जी सर।
अब कह रहा है कि कैलकुलेट द डिक्रीज इन हॉरिजॉन्टल मोमेंटम ऑफ द mass ऑफ द वाटर इन द ड्यू टू हिटिंग द वॉल। तो मोमेंटम में आपने डिक्रीज फाइंड करना, तो आप कोशिश करो यहाँ पे ये फॉर्मूला डेल्टा पी से लेके आओ। तो डेल्टा पी इज इक्वल टू एम वी माइनस एम यू आपका लगेगा। पहले फॉर्मूला सही लगाओगे, फिर आपको सही आंसर मिलेगा, ठीक है। अदरवाइज आपको आंसर नहीं दे, वो मार्क्स नहीं मिलेंगे।
सर
बाकी
मैंने
सब सही है,
मतलब ऑलमोस्ट सेम।
आपका फार्मूला सही है, क्योंकि आपने यहाँ पे उसने बोला है डिक्रीज इन मोमेंटम। तो या तो आप डिक्रीज इन मोमेंटम के लिए फार्मूला ना लगाओ, आप सिंपली ये कर लो कि 1.2 इंटू 5, तो 6 न्यूटन सेकेंड्स, ठीक है, ये भी सही है। लेकिन अगर आप फार्मूला लगाते हो तो आपने डिक्रीज का रेफरेंस देना है, ठीक है।
ओके।
ओके, उसके बाद कह रहा है मैग्नीट्यूड ऑफ द हॉरिजॉन्टल फोर्स एक्सर्टेड ऑन द वाटर बाय द वॉल। तो फोर्स इज इक्वल टू डेल्टा बी बाई टी, ठीक है, आपने ये फॉर्मूला सही लगा हुआ है। देन 6 इज द चेन इन मोमेंटम। अब आप देखो ना, चेन इन मोमेंटम को रिप्लेस कर रहे हो ना आप, बात समझ आ रही है ना? ये लॉजिक आप वहां ऊपर, आपका एग्जामिनर आपको मार्क्स नहीं देगा। अगर आप सिंपल वी लिखोगे तो योर मार्क्स विल बी डिटेक्टेड। तो डिवाइड बाय दिस, तो आपका आंसर क्या आ रहा है? 3.8 न्यूटन। ठीक है, इज इट क्लियर? कैलकुलेशन सही है ये? ओके, state and explain the magnitude of the horizontal force on the wall by the water। तो यहाँ पे एक्चुअली आपको न्यूटन थर्ड लॉ के मुताबिक आपको काम करना है। तो फोर्स एक्सर्टेड बाय द वाटर is 7.5 Newton. So force exerted by before hitting is equals to the force exerted after hitting. नहीं, you will not be awarded marks here। okay, अब before and after तो है नहीं। आपके पास जिस टाइम वाटर वॉल को जाके हिट कर रहा है, उसी टाइम वो फोर्स एक्सर्ट कर सकता है, और उसी टाइम उसके ऊपर फोर्स एक्सर्ट हो रही है। आपने ये देखना है, दिस इज फोर्स ऑफ वाटर, ठीक है, वाटर, एंड दिस इज फोर्स ऑफ वॉल। तो फोर्स ऑफ वॉल, तो आप लिखोगे, ये एक नंबर है, सीधा सीधा आप ये लिखोगे कि अकॉर्डिंग टू न्यूटन थर्ड लॉ ऑफ मोशन। ये एक्सप्लेन का वर्ड आ गया, इसलिए मैं ये लिख रहा हूँ, अकॉर्डिंग टू न्यूटन थर्ड लॉ
Every force has an equal
द
and
फोर्स
opposite
विल बी इक्वल एंड अपोजिट।
reaction.
यस, एग्जैक्टली, फोर्स विल बी इक्वल एंड अपोजिट। ठीक है जी।
जी।
तो 3.75 न्यूटन फोर्स लगेगी इसके ऊपर, सही है। तो कैलकुलेट प्रेशर एक्सर्टेड ऑन बाय द वॉल। तो प्रेशर इज फोर्स पर यूनिट एरिया, तो फोर्स आपने कैलकुलेट कर ली। यहाँ पे कोशिश करो आप 3.75 लिखो, बिकॉज द कैलकुलेटेड आंसर आपने यहाँ पे लिखना है इंटू 10⁻⁴। तो ये आपके पास 2.5 इंटू 10⁻⁴ पास के लिए आपके पास आ गया। इज इट क्लियर?
Okay.
ओके, उसके बाद आपके पास आ जाता है क्वेश्चन नंबर 2। क्वेश्चन नंबर 2 में ये प्रोजेक्टाइल का क्वेश्चन है, और वो कह रहे हैं कि वाटर लीव्स द एंड ऑफ द होज। ये एक्चुअली उसी को कंटिन्यू भी किया जा सकता है हमारा ये क्वेश्चन, राइट। पी, द हॉरिजॉन्टल वेलोसिटी ऑफ द वाटर इज 6.6 मीटर पर सेकंड एज शोन इन द फिगर। पाइप से वाटर 6.6 मीटर पर सेकंड की स्पीड पे एग्जिट किया उसने, एंड इट ड्रॉप्स ओवर हियर बाय ट्रैवलिंग अ डिस्टेंस ऑफ 3.5 मीटर्स, और हाइट आपके पास h है, इट इज नॉट गिवन टू यू। ठीक है, अब वो कह रहा है एयर रेजिस्टेंस नेग्लिजिबल। ये एक इंपॉर्टेंट इंफॉर्मेशन है, इसको आपने ध्यान में रखना है। assume that the water between P and Q consists of the non-interacting droplets, यानी एक stream of water है, ये सीधी सीधी यहाँ पे जाके हिट करती है। Explain briefly why the horizontal component of the velocity of the droplet of the water remains constant as it moves from P to Q। P to Q हॉरिजेंटल वेलोसिटी का जो कंपोनेंट है, वो हम तो वैसे कहते हैं कि हॉरिजेंटल वेलोसिटी कांस्टेंट होती है, लेकिन यहाँ पे वो बोल रहा है कि कांस्टेंट होती है। आपको रीजन बताना है, आपने ये बताना है बिकॉज एयर रेजिस्टेंस नेग्लिजिबल, उसने मेंशन भी किया हुआ है। आप लिखोगे कि बिकॉज नो एक्सेलरेशन अलोंग एक्स एक्सिस। ठीक है, ये चीज आपको बहुत बार बताई है मैंने, एक्सेलरेशन अलोंग एक्स एक्सिस। और अगर आपके पास एक्सेलरेशन अलोंग एक्सिस नहीं है, तो दैट इज नो रिजल्टेंट फोर्स अलोंग एक्स एक्सिस, या अलोंग हॉरिजॉन्टल भी कह सकते हो। ठीक है, उसके बाद वगैरह कि शो दैट द टाइम टेकन फॉर द ड्रॉपलेट्स ऑफ द वाटर टू मूव फ्रॉम पी टू क्यू इज 0.53 सेकेंड। पी टू क्यू मूव करने के लिए आपको ये देखना है कि उसको 0.53 सेकेंड्स लगे। तो बेसिकली आपने बड़ा अच्छा उसके ऊपर अटेम्प्ट किया है। यू यूज एस इज इक्वल्स टू वी टी, एंड टाइम इज इक्वल्स टू एस बाय वी कर दिया आपने, या डिस्टेंस डिवाइडेड बाय वी। सो 3.5 इज गिवन टू यू, और 6.6 आपके पास अब कैलकुलेशन, ये ऊपर वेलोसिटी आ गई, ठीक है। तो आपने इसको डिवाइड किया एंड यू गॉट 0.53 सेकेंड्स। उसके बाद आ रहा है कैलकुलेट हाइट। तो आपने हाइट कैलकुलेट करनी है, तो फॉर योर हाइट कैलकुलेशन, क्योंकि दैट इज वाई एक्सिस, तो वाई एक्सिस इज एक्सेलरेटेड मोशन, तो एक्सेलरेटेड मोशन में आपने अच्छा किया है, आपने किया हाइट इज इक्वल टू 1/2 GT²। अब यहाँ पे आपने जब बॉल को देखा, आपने जब बॉल को ड्रॉप करना है ना, H इज इक्वल टू UT+1/2 AT²। एक्चुअली तो ये इक्वेशन लगी हमारी, इसमें आपका ये जीरो हो गया, दैट्स वाई आप लोग आपने क्या किया, यू सिलेक्टेड दिस वन, तो 1/2 GT², ये आपके पास आ गया 1.4 मीटर, ठीक है। कैलकुलेशंस ओके अगर हैं तो आपका आंसर यही आना चाहिए। उसके बाद आपको बोला है फॉर द मूवमेंट ऑफ द ड्रॉपलेट ऑफ द वाटर फ्रॉम P to Q स्टेट एंड एक्सप्लेन वेदर द डिस्प्लेसमेंट ऑफ द ड्रॉपलेट इज लेस देन आर इक्वल टू आर सेम, मतलब द डिस्टेंस अलोंग द पाथ। तो आपको पता है कि डिस्टेंस और डिस्प्लेसमेंट कभी सेम नहीं हो सकते। द वाटर ड्रॉपलेट, यानी द डिस्टेंस ट्रेवल्ड फ्रॉम P to Q इज नॉट अ स्ट्रेट लाइन, whereas the displacement will be a straight line. That is why displacement is will be shorter than distance, ठीक। it will be same because it is horizontal direction। नहीं, बात समझ आ गई आपने क्या गलती की हुई है। आपने ये लिखना है कि the displacement is shortest distance,
Okay.
displacement is shortest distance, so not equal, ठीक है। उसके बाद है कैलकुलेट द मैग्नीट्यूड ऑफ द डिस्प्लेसमेंट ऑफ द ड्रॉपलेट। तो अब आप
Yes,
देखो
sir.
आपने यहाँ पे गलती की, आपको डिस्प्लेसमेंट का कॉन्सेप्ट आपको उसने खुद समझाया है कि ये आपका 3.5 मीटर है, और हाइट आपने कैलकुलेट कर ली, हाइट कितनी कैलकुलेट की थी, 1.4 मीटर, ठीक है जी, 1.4 मीटर। तो
Yes.
डिस्प्लेसमेंट आपका कैसे आ जाएगा, दिस विल बी द डिस्प्लेसमेंट ना, है ना। तो अगर ये डिस्प्लेसमेंट आता है आपका,
Uh,
तो आप क्या लगाओगे इसके ऊपर, पाइथागोरस लगाओगे कि नहीं लगाओगे। तो आप करोगे 1.4 का स्क्वायर प्लस 3.5 का स्क्वायर, स्क्वायर रूट, दैट इज योर डिस्प्लेसमेंट। करिए जरा क्या आंसर आएगा।
3.76.
ठीक है, ये बात क्लियर है।
जी सर।
3.8 मीटर सही हो गया। ओके, क्वेश्चन नंबर 3 पे आओ। क्वेश्चन नंबर 3 भी बहुत ट्रेंडिंग क्वेश्चन है। कह रहा है कि अ मैन standing on a wall throws a small ball vertically upwards with the velocity of 5.6 meter per second. The ball leaves his hand when it is at a height of 3.1 मीटर। यहाँ पे जब बॉल वापस आया तो 3.1 मीटर की हाइट पे उसके हाथ को उसने छोड़ दिया above the ground as shown in the figure. Assume that the air is negligible. Very important sentence. Show that the ball reaches to the maximum height above the ground is 4.7 मीटर। तो क्वेश्चन इज सिंपल, लेकिन आपने ये देखना है कि when the ball is leaving the hand of the person, its initial speed is how much, 5.6 meter. So finally its final velocity would be equal to zero against the gravity. आपने यहाँ पे अगर आप डाटा लिखना चाहो तो लिख सकते हो, लेकिन जरूरत नहीं है। और v इज इक्वल टू जीरो, और g की वैल्यू आपको पता कितनी है, -9.8 है, बिकॉज दैट इज मूविंग अपवर्ड एंड यू आर सपोज टू कैलकुलेट हाइट, ठीक है। और हाइट भी कहाँ पे, अबव द ग्राउंड। सो पहले तो आप हाइट फाइंड करोगे अबव द हैंड्स, ठीक है। ये तो मैं इसको कर लेता हूँ, दिस इज द हाइट अबव द हैंड्स, या हाइट फाइंड कर लो, नो इशू एट ऑल। तो आप इसके ऊपर फॉर्मूला कौन सा लगाओगे, वही h इज इक्वल टू 1/2
of g
GT स्क्वायर, ठीक है। तो यू विल गेट 1/2 माइनस 9.81। वैसे मैंने यहाँ पे नेगेटिव लगाया था, आपको नेगेटिव की जरूरत नहीं है, जस्ट आप इसको 9.81 लगा दो, बिकॉज आई हैव फ्रेम्ड द इक्वेशन कि 1/2 9.81 इंटू टाइम कितना ले रहा है वो।
टर्म मेंशन नहीं है।
ओह सॉरी सॉरी, नहीं टाइम की हाँ, हम टाइम वाली इक्वेशन नहीं लगा सकते, सॉरी सॉरी, हम टाइम वाली इक्वेशन नहीं लगा सकते, बिकॉज टाइम नहीं है, मैं अनफॉर्चुनेटली मैंने समझा टाइम है। तो आप यहाँ पे सीधी सीधी इक्वेशन लगाओ, 2as वाली थर्ड इक्वेशन ऑफ मोशन लगा दो। जब हम थर्ड इक्वेशन ऑफ मोशन लगाएंगे तो हमारे पास ये कैलकुलेशंस हो जाएंगी क्या, 2gh इज इक्वल टू v स्क्वायर माइनस u स्क्वायर। तो ये आपकी हाइट हो गई 1, दैट इज इक्वल टू v स्क्वायर 0 माइनस 5.6 का स्क्वायर डिवाइडेड बाय 2 इंटू 9.81। ओवरऑल कैलकुलेशंस करके दीजिए मुझे, क्या आंसर आ जाएगा ये। यहाँ नीचे भी नेगेटिव है तो नेगेटिव नेगेटिव पॉजिटिव हो जाना चाहिए।
1.59।
ठीक है, 1.5 अबव हैंड्स।
जी।
अब हमें हाइट फाइंड करनी है फ्रॉम द ग्राउंड। तो आप ये कर लो कि हाइट फ्रॉम द ग्राउंड इज हाउ मच। आपको बॉल ऑलरेडी कितना है,
1.
3.1 मीटर ऊपर है ना।
जी जी सर।
तो दैट इज 4.7 मीटर। ये बात क्लियर हो गई। ठीक है जी।
ओके। ये आपने अबव हैंड क्यों फाइंड किया अभी?
देखो मैं समझाता हूँ, पहले आपका बॉल ऊपर जाएगा, अगर मैं इसी को डायग्राम की फॉर्म में लेके जाऊं तो आई कैन से कि बॉल यहाँ से ऊपर गया, वहां से फिर वापस आएगा, ये है ना। तो ये जो हाइट है ना आपकी,
जी सर।
ये वाली, ये 1.6 मीटर है, ठीक है, ये 3.1 है। तो ग्राउंड से ये कितना ऊपर हो गया,
4.7।
3.1 प्लस 1.6, 4.7, ऐसे ही है। बात समझ आ गई।
जी सर। यस
ओके,
सर।
बंद करो। ठीक है, भूलोगे तो नहीं ना आप।
नो सर।
ओके, अब उसके बाद बोल रहा है, बंद करो दरवाजा, ये लो, दरवाजा बंद करो। कह रहे द मैन डज नॉट कैच द बॉल एज इट फॉल्स। ये प्रॉब्लम आया कि वो बंदा इसको कैच नहीं कर पाया। कैलकुलेट द टाइम टेकन फॉर द बॉल फ्रॉम द मैक्सिमम हाइट टू द ग्राउंड। तो अब आप देखो, अगर मैं दोबारा यहाँ पे डायग्राम वही वाली बनाऊं, तो दिस वाज द पॉइंट जहां से उसने बंदे ने बॉल को ड्रॉप किया ऊपर। तो बॉल वेंट अप, देन इट स्टार्टेड इट्स जर्नी बैक टू द ग्राउंड, दिस इज द ग्राउंड। तो आपकी यहाँ पर इनिशियल स्पीड क्या है, 0 है। नाउ द बॉल इज ड्रॉपिंग डाउन, है ना। तो व्हेन द बॉल इज ड्रॉपिंग डाउन, आपके पास बॉल यहाँ पे आके हिट करेगी फाइनली। वी डू नॉट नाउ अबाउट द वेलोसिटी, इसलिए मुझे इससे कंसर्न नहीं है। आपको हाइट गिवन है,
So when we adding t with the t square, right? So I can't hear you.
Now do you hear me?
Yes.
Okay. मैं ये कह रहा था कि when you multiplied this zero with t, then what will you get?
Zero. Yes.
Then why did you write t here? This is the problem, right? Just
Accidentally.
eliminate t. T is not no more there. So it is 4.7 is equals to 4.9 t square. So just solve it. Your t square will be equals to 4.7 divided by 4.9. And when you will find t, take square root on both sides. So your t will be, just इसका square root लेके दो मुझे. What will you get?
0.979. Same answer.
0 point. कैसे हो गया है? प्रिंस विलियम
979.
हैरिस. Just do it again. 97998. ये जरा क्यूब करके देखना दोबारा. क्यूब रूट ले लो इसका. इसका 4.7 डिवाइडेड बाय 4.9 इसका क्यूब लो.
0.98.
0 point.
Same answer. 0.98. 986.
क्या बात है भाई. But you have to take square root, not cube root. Okay?
Okay, the answer is
This is the
correct.
right
Okay.
answer. Got it now? Now the game is for part C. Part C, a ball leaves the man's hand at time t is equals to 0 and hits the ground at time t is equals to capital T. Okay? On figure 3.2, sketch the graph to show the variation of velocity of the ball with time t from time t is equal to 0 to time t is equal to t. Numerical values are not required. Assume that v is positive in the upward direction. V is positive in the upward direction. Okay. So when v is positive in the upward direction, so आप देखो, when it is leaving the hands, वैसे velocity आपके पास क्या है? 5.6 ना. So just assume one value
Yes, sir.
कि that is 5.6. ठीक है. अब 5.6 मुझे सिर्फ एक चीज बतानी है आपने कि when it will hit the ground, will its velocity will be 9.6, less than 9.6 or more than 9.6?
It will less than, right? But rebound.
Okay. Okay. अब इसको देख के मुझे बताओ. The above distance is 1.6 meter. Got it? है ना?
Yes, sir.
And the
Yes.
distance below that is 3.1 meter. So when the ball is leaving the hands of the person with a speed of 5.6, when will it reach back to this point? What will be its speed? Here.
Same.
Same, exactly. And now it is continuing its motion downward. So what will be its speed till this point? More than 5.6 or less than 5.6? भाई इतना बता दो.
So when it falls down, right?
Yes, when it falls down and it hits the ground, so what will be its speed? Less than
It will be more than.
9.5? It will be more than, exactly. When it will be more than 9 point,
Yes.
yani 5.6, you will simply draw the graph in this way. Your graph will be like here. I'm just going to draw it roughly. So let's say this is your 5.6. Suppose this is your 5.6 point, this one. Then it will take short time to come back, and then remaining time it would go down. So you will have this type of graph. This area will be small, this area will be more. Got it? Are you getting it? And the speed over
Yes,
here,
sir.
that will be greater than. So it means if this point is indicating 5.6, this point will indicate more than 5.6. Let's say 10 point something or 11 point something. Are you getting my point?
Yes, sir.
So your graph will be just a straight line. You can start it from anywhere, but the ending should be at a point higher than or more than this value. Simple. Is it clear to you?
Yes, sir.
Okay. Now I will mark these points. Just enhancing the question. These are 3 points. Can you please explain me what is this point A, what is this point B, and what is this point C? Yes. What is A?
Sir, it's an initial velocity rate from where it starts.
Yes. Here, when it is dropped, thrown upward at a speed of 5.6 meters per second. And what is this point B?
Sir, where the ball hits the ground. I mean,
No,
where the ball is still in
at the
motion,
highest,
going.
when it is at the highest point, when the ball is at the highest point,
Yeah.
here it is at the highest point. Okay.
Okay.
So you can say that is the point B. And what about C?
Says
C is the
where
point where
it
it
touches
hits
the.
the ground.
Yes.
Okay. One more question. Throughout this journey, what about the acceleration? How will you brave it?
So acceleration remains constant.
Yes. And what is this value?
9.81.
Very good. 9.81. Clear?
Yes, sir.
So this was basically one of the perfect question. Yes. Now state what is represented by the gradient of this graph. So you have stated that it is acceleration. So you will score a mark here. And then a man now throws a second ball with the same velocity. Same velocity. This is really, really important word. Same velocity. Okay. And from the same height as the first ball, the mass of the second ball is greater than the first ball. Mass of the second ball is greater than the second ball. Assume that there is still negligible. Then for the first and second ball, compare the magnitude of their acceleration. So remember one thing, very interesting question, that if we have different masses, but the velocities are same, right? Initial velocity, whatever the ball is, it does not matter. But the velocity by which it is being thrown upward here, whatever its mass is, it will reach to the highest point in the same time. It will cover the same distance, and each and every parameter would be same. That's why you just write that acceleration will be either same or equal, etc. And the speed by which that hits the ground, it would also be same, or you can simply like equal. Okay,
Okay.
is this clear to you?
So my
Okay.
answer is yes. Okay.
Yeah, your answer is same. Your answer is correct.
Okay.
Got it? Okay. Now, question number four. Question number four is related with dynamics, and further more in dynamics, it is related to momentum, and further it is related with the angular, yani the glancing momentum, the momentum at certain angle. So, state the principle of conservation of momentum. So you have stated that momentum before collision is equal to momentum after collision. So here one more sentence you have to add, that in a closed system or in an isolated system.
Okay.
These two words are really, really important.
Okay.
Okay. So if you will write only
Yes.
this part, what you have written, so you will score 1 mark here. Okay. Then part 2, part B, the two balls X and Y move along the horizontal frictionless surface. Important line. So that is the frictionless surface as shown from the above. This is the top view. This ball is having mass 3.0 kg. This has a mass of 2.5 kg. Ball X has a speed of 4 meter per second and ball Y has a speed of 4.8 meter per second, and both are making an angle theta with a horizontal line or the line of motion. Right? Simple. The drawing is not at scale, not at scale. This is before collision. This is your after collision. So the question is, by considering, oh, one more thing. Both the balls are joined together after collision, and they
Sticky.
move with the same final velocity as 3.7 meter per second. So it is the evidence that this is the sticky collision. Got it? So in sticky collision,
Yes,
by
sir.
considering the components of momentum along the line AB, calculate theta. This is my question. And in that question, there is a clear indication considering the components of momenta along line AB. So you have to consider both the components basically. So you have selected V1, M1, V1 cos theta 1 plus M2, V2 cos theta 2 is equals to M1 plus M2 into V. Okay, that is good technique. So 12 cos theta plus 12 cos theta is equal to 3.7 into this. Good. And 24 cos theta is equals to 20.35. Okay. And cos theta is equals to this. So it is 32 degree. Okay. Now you can simply say, yes, you have selected or you have resolved the components of x into 2, one in this direction. This was your basically 3 into 4 into cos of theta, and this one is your 3 into 4, yani 12 sine theta. Similarly, this one is this one is 12 sine theta, and this one is 12 cos theta. Very good. So you did it all, and here it will be 3 plus 2.5 into 3.7. So when you completed this all, you got 32 degree. So this is basically theta in degrees. Okay, ji, got it?
Yes, sir.
Okay, good. So you scored 3 marks here. Okay, by calculation of kinetic energy, you are bound to do such calculation of kinetic energy and state and explain whether the collision of the ball is elastic, sorry, inelastic or perfectly elastic. So as you know that in sticky collision, although that is inelastic, but you have to calculate because you have to give a reference. So kinetic energy before collision you can write is 1 by 2 m v square. What did you do here? Okay, this is kinetic energy after collision, isn't it? Yeah. What did you do here?
Yes, sir.
Is that
So the left side is before collision and the right side is after collision.
okay? Okay. 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 So here I can say that this is your kinetic energy one, and for kinetic energy one, 1 by 2 m1 u1 square plus 1 by 2 m2 u2 square. So 1 by 2 mass is 3, initial speed is 4, 1 by 2 plus 2.5 into this. Okay, you have just placed all the values instead of formula. So it is 53 joules before cooling. Is calculation correct?
Uh, yes, sir. It should be.
Okay. And 1 by 2 kinetic energy 1 by 2 m1 plus m2 into v square. So 1 by 2 5.5 into 3.7 square. Okay, almost it is 38 joule. So kinetic energy is lost. So what is your conclusion actually? Is it elastic or inelastic? Inelastic. As kinetic energy is
In a
lost.
lab.
So you will score 2 marks there. Got it? Because kinetic energy is lost, that's
Yes.
why it will be inelastic. So you scored all 7 marks here. Very good. Okay. Next question. That is question number 5. And that is basically related to the following list of underline the units that are SI base units. So SI base units are, one is ampere and the second one is your kilogram. So both correct, 1 mark. Okay. Then there is a block and that block is oscillating. That is fixed from 1 point. The question is just very clear. There is a block placed on a beam, and due to that, there is a Young's modulus of the beam or the metal beam is given by E is equals to K M divided by T square, where M is the mass of the block, T is the time period of the oscillation, and K is the spring constant. The values you are having, all values have some percentage uncertainty in them. K की uncertainty है 2.1%, plus minus the uncertainty in M is 0.6%, and uncertainty in T is 1.5%. Student uses the value of K, M, and T to calculate the value of E as 8.245 into 10 to the power 9 Pascal. It is given to you. So that is basically your good luck. The question is calculate the percentage uncertainty and all these values. So what did you do? You have used this E is equals to Km divided by T square, this formula which is given to you. A is equals to Km divided by T square. So that is E is equals to Km divided by T square, mean percentage in E is equals to percentage in K plus percentage in M plus 2 times percentage in T. So your final answer is 2.1%. K value of K is 2.1%. For M it is 0.6%, and for T it is 1.3 into 2. So it is 5.7%. Very good.
Sir,
Yeah.
sir, is okay if you write
Yes.
6% round up?
Yes. Yes. Actually, it is not mandatory to write one significant figure here, because that is percentage uncertainty. It's not the absolute uncertainty, right? It is percentage uncertainty. Is it clear to you?
Okay. Yes, sir.
So, in percentage uncertainty, usually we write the answer into two significant figures because we have to calculate absolute uncertainty from this one. So we do not round it off too much. So the game is here. That what I told you. So what is advised to you? Your answer in B1 determine the value of E with its absolute uncertainty to an appropriate number of significant figure. That's it. Here you have to calculate. So uh, instead of writing this 8.24 exponent 8.245 exponent 9 into 5.7, it is just like percent with it. So when you will write percent in it, what does it mean? You have to divide this number by 100. Okay, here you made
Yes,
a
sir.
shortcut. I don't know why. How did you make a shortcut here?
No, sir. I typed like I did it correctly everything in the calculator.
Okay, so delta E by E is equals to 5.7%. So just we are working for delta E. So delta E is 5.7 times what is value of E? 8.245 into 10 raised power 9 divided by 100, because I'm just converting it to delta E. Okay, so can you please calculate it for me? Where is your calculator? 4.7.
4.69 10 to the power of
Mm-hmm.
10 to the power of 8.
10. 8 or 10?
It's I think 8. Wait,
Okay, just count it.
yes,
No
it's
issues at
8.
all. Okay,
Yes, it's 8.
so because you have to represent in it in power of 9, so you can make it 0.469 into 10 raised power 9. So you will round it off as 0.47, which would be further rounded off to zero point 0.5 as one significant figure into 10 raised power 9. So you did it very good. And now you will round the number in according to the decimal place of your value, uncertainty. So how much dp do we have? 1.
1 GP. Yes.
Yes. So you will simply write the answer. You will not score mark here for this one. You will write the answer as 8.2, because 5 will be dropped. It will have no impact on 4, and 4 will be dropped. It will have no impact on 2. So your answer is 8.2 plus minus 0.5, right? And 10 power 9 is already given to you. Is this all clear to you?
So
So unfortunately, you will score 1 mark here. Okay. Now in question number 6, state the condition for the body to be in equilibrium. So the body should be in rest. In rest, instead of that, you can write at rest. Or should be balanced. No, 0 mark. Because you will write two conditions. Sum of all the forces equals to 0, equal to 0. This is condition number 1. And condition number 2, sum of clockwise movements equals to sum of anti-clockwise movements. Is it clear to you?
yes, sir.
Okay. Now the next question, this is really, really important question. And Mean perfect conceptual question. A ladder is rests a ladder rests in equilibrium on the rough ground. Really important information. And a rough wall. Rough ground and rough wall means this rough ground and rough wall will not let the ladder to slip down, or it will not let the ladder to slip away. Got it? It means that this roughness of the wall is providing a friction force of the wall here, and this is the friction of your floor. These two forces are confirmed in this direction, then this is weight of that. And secondly, the ladder is pressing the wall in this direction, so that the wall is applying a force backward in this direction. So this is force of wall, yani pressing force of wall. And here the ladder will press the ground downward. So as a result, the ladder will be pressed, yani ladder will be having a force upward. So this is force of floor on the ladder. So these all are the forces acting on the ladder in this situation when it is placed here in front of you. Now, is this clear? So more than
Yes,
half of
sir.
the question is solved. Yes, all of your circles are now clear. The way to, okay, draw two vectors at point P to show the forces acting on the ladder by the rough wall. Label them A and B. So here at point P, unfortunately, we put FWP and FW, but simply one can be labeled as A and one can be labeled as B. Got it? You can name them
Yes, sir.
A arbitrarily. It is not mandatory. Now you have to explain that why I have, yani what is force A and what is its origin. What is force A here? Just consider. It is the normal reaction of wall. Is it not? A is which is towards left. So force A normal reaction force, and source is push of ladder at wall. Okay. What about force B? Force B is friction force. And this force, what is the origin of this force? Rough wall.
Rough.
Okay, ji? Got it.
Yes, sir.
So that is why no point till now. Draw a vector triangle in the space beside figure 3 to show that the resultant vector A and B is represented by P. Yes, here is the diagram space. A is in this direction, B is in this direction. And what will be the resultant, by the way? This is a vector diagram. It is not vector triangle. So it is what? Vector diagram. For vector triangle, you will say that one force is here. This is A, this is B, head to tail, and this is basically the result. Is it clear to you? So if you will score one, you will score 1 mark here.
Okay.
On figure 3, draw the vector at point Q, show the resultant force. So I did already. So in the space below, draw the vector triangle. So I told you that at point B, there is a normal reaction force of the wall, sorry, friction force floor, normal reaction force of floor, then friction is acting in this way. This is your friction, and the resultant will be anywhere here. So when we are going to make a vector diagram for that one, you make it friction arrow. On the head of this, you can draw a normal reaction force, and along with that, you can draw a resultant. Okay, so
Yes, sir.
it means here normal reaction force is this way, and here normal reaction force is this way. Yani overall resultant force. Just keep all these points in your mind. This was a entirely ladder question, so this, I believe that now it would be clear to you. Is it clear?
Yes, sir.
Question number 7, 8, 9. Three questions are left. So okay, okay. Yeah, it would be done inshallah. Just give me 5 to 10 more minutes. Correct. Question number 7: a motor drags a 450 kg up the slope by mean of a cable, and that is making an angle 14 degree with the horizontal, and it is dragged to 10 meters up the slope, and the log show that the component of the weight of the log acting on the slope down the slope is 1070. So its mass is this much, 450 kg. So when I will resolve it just in this way, nothing else, when I am going to resolve this is its mg, this is its normal reaction force, and basically this is the component which is its mg sine theta, that component. So mass is given to you 452 into 9.81 into sine 14. So it is almost 1072. So you can write 1071 Newton. Unit will be written here. Okay, anyhow, you will score a mark here. Then the log is starting from rest. Important information. Important information. Constant 525 log, the log accelerates up the slope at this rate. Calculate the tension in the cable. So this is that question in which you must have a clear concept of the forces. Just see, this is the cable, so it would have a tension definitely, because that is pulling it up. Yes, there is a constant friction in this direction. Friction is there, and this mg sine theta, that is also behaving just like an opposing force. So you have all the forces here that on this wooden log. This is driving force, and this is your opposing force, and this one is your mg sine theta. So mg sine theta and friction, they are in the same direction. Driving force is the tension force. So you can simply say that F net is equals to F driving minus F resistive. So that is equal to MA, and driving force is tension in the rope, and F R resistive force is mg sine theta minus friction. So everything is given to you. Just make a subject of tension. टेंशन इज इक्वल टू
Yes, sir.
ma plus mg sin theta plus friction. Just calculate them all.
Yes, sir.
Your mass is 542. Where is the mass? 452, sorry. Your mass is 452. Your acceleration is given. What was the acceleration? 0.13 meter per second
30.
square. Again, it is 452 into value of g is 9.8 into sine of 14. So what is friction? 525. Okay. So can you calculate the tension? What will be the value of tension here?
Sir, 1131.47.
So it is almost 1130 Newton. Okay. Is it clear to you?
Yes, sir.
Okay. Then question number 8. Define the torque of a couple. The torque of the couple turning effect of a force around a pivot. You can simply say that is the turning effect of a couple. So turning effect of yani it is the product of any of the couple force or any of the couple forces and perpendicular distance between the forces.
So my answer is wrong.
Yes, turning effect of the force around a pivot. You can score 1 mark here instead of 2. Okay?
Okay.
Because it is defined torque of a couple, not a simple torque. So
Okay.
like this, calculate the torque of on the rod produced by force A and B. So you did it. So you just use any one of the force and the perpendicular distance between them. So you got 0.112 Newton meter. Describe briefly whether the rod is in equilibrium. No, the rod is not in balance because uh, no, the rod is sorry, the forces are not balanced and no, there is no game of forces at all. You can say as moment is not zero. So, oh, sorry. Just a second. Moment is zero. Moment is not equal to zero, but what is the condition behind that? This is 8 Newton force upward, downward. They are equal, and this is basically a force which is not shown to you. It is hidden for you, but there will be a force acting in the upward direction. ठीक है जी? So forces are balanced, but the moment torque, the
Yes,
moment, yani resultant moment is not equal to zero. ठीक है? So you said that no, the forces are not balanced, resolving into resultant force. नहीं, it is zero. Okay, clear है?
जी सर। तो मैंने यहाँ फोर्सेस नहीं लिखना।
नहीं, forces लिखना है, लेकिन आप लिखोगे कि forces are balanced, not नहीं लिखना फिर। बल्कि आप ये भी लिख दो
Okay. समझा.
कि forces are balanced but moments are not balanced. The log is initially at rest, so it is starting from its initial speed rest and pulled through a distance of 10 meters. Calculate for the log the time taken from S to P. So S is equal to UT plus 1 by 2 AT square. Okay, very good. 1.2 into, yes, into T square.
Correct answer, sir.
Calculations, are these calculations correct? I doubt it that, okay, the answer is almost same because I do not have a marking in front of me, but answer will be same. Approximately, yeah, there will. The magnitude of the velocity at point P. So magnitude of the velocity at point P, point P, point P, point P. Okay, I think there was a page missing out. This question is not related to movement. This is a part of previous question. So 2as is equal to v square minus u square. So 2as is equal to v square minus b square. So v square is separate out. So 2a s divided by this. What did you do, man? What is here? Subhanallah. Subhanallah.
Just-
Can you please again solve this number for me and give me your answer equal to 1.6? Just you have to divide
So,
by 1.6.
yes, sir. I didn't hear you.
Yes. Can you please calculate this number and can you tell me your answer? This number.
Sir, so divided by 0 will be the same as 1.6, so it won't change, right?
Why did you divide it by 0? This is my question basically.
So because uh, u is 0.
U is 0. Oh my god. U is 0. So when U is 0, so will it not be 0 here?
Yes, sir.
Yeah, if U is 0, so how did you frame this equation to this equation? Can you please explain it to me? वो हमारी चीज़ आसान शुरू कर। एक बेटा बस। Yes, Shoaib. If
Yes, sir.
2s is equal to v square minus u square and u is 0, so will this 0 be shifted in the denominator directly without any rule regulation?
Uh, I
Did you
think sir
ever
मैंने
take
गलत एरिया
mathematics
अरेंज
in
किया.
your life?
वो गलती से गलत अरेंज हो गया.
Ah, this is the problem. So when you arrange it as 2as equals v square minus u square, and you now that u will be 0, so don't skip the steps, just rewrite it as it is 2as is equals to v square. And from here, no need to go anywhere, just 2a and s. Put everything in the same sequence, just don't write it because it will make everything infinity. Got it?
Okay.
MashaAllah. You have divided with 0 with in calculator, and how did you get 1.6 by the way?
No, no, no. I didn't keep those
Really?
zero. I just ignored it.
Oh my
Yes.
god. Just You just kept this zero as a relic with you. Huh? Okay, now is it clear to you? So your answer will be 1.6 meter per second.
Yes.
Now in this one, the cable breaks when the log reaches to a point, and figure 2.2 sketch the variation with time t of the velocity v of the log. The graph should show v from start to s until the log returns to s. 4 marks question. So very interesting question. Just go back to the log. Where is the log? Man, you have mixed the questions. Okay, log is starting from rest. It means it's starting is okay. I'm just going to sketch a small minor graph here just to make you clear. So initial speed should be zero. The block is accelerating at a rate of 0.13 meters per second square. Ah, yes, it means it will have a constant gradient like this till this point here, and here the rope will snap. It means the block will not come to zero at once. It will take some time, it will go to rest, and then it will slide down, because now there is no more cable. So when there is no more cable, what will happen to that? The block will go down. Are you getting my point? Your rope is snapped here. Okay, rope was plugged out, and now the block would, at this stage, block had a speed which is not equal to zero, and you have calculated that it was 1.6 meter per second. So this 1.6 meter per second will take some time to get zero, is it? Do you agree?
Yes, yes, sir.
So when it will take some time to get zero, it means maybe it will be here, it will be zero here, let's say. So here its speed goes to zero. But once it will be zero, then the block will slide down back here. So because it is now under the influence of uh, you know friction will be definitely constant there, and the block is now only under the influence of mg sine theta. That is why your graph would be something like this. Okay.
Yes, sir.
Okay, so here you will just draw the graph, first line, and then you will just do it in this way, and then you will make it further on y-axis. Sorry, here. Okay.
Yes, sir.
Okay, is it clear to you?
Okay, sir.
Okay, now let me calculate your score. Okay. Okay.